Welcome back to the Deep Dive. So today we're going to try and pull generative AI out of that whole cycle of, abstract digital art and text bots. We're grounding it in the thoughtful world. For you, the learner, this is the essential shortcut on how Gen AI is really starting to reshape the design process. We're talking how buildings are conceptualized, infrastructure, even how products are engineered. And our mission, well, is pretty clear. We need to unpack how this computational power really revolutionizes conceptual design, how it helps firms find these incredibly innovative, sometimes really surprising forms, while also sticking to the messy real-world limitations. Things like gravity, budgets, building codes, all the non-negotiables.
And that balance you just mentioned, that's everything. That's the key. Design has always been a negotiation with reality, right? Historically, creativity was sort of capped by the speed of human iteration, the known limits of materials and physics. You might spend 6 months on a spectacular cantilever design.
And have no time to test alternatives.
Exactly. No time to test 20 other ways to bear that load. What's so different now is that Gen AI's real power isn't just generating endless possibilities. It's balancing that infinity with practical constraints. Structural integrity, economics, regulation. It does it all at once.
Right. A structure that looks phenomenal but, needs a material that doesn't exist or breaks local zoning laws. It's a failure. It's useless.
Yeah.
So let's start where the magic happens, the engine room. When a designer feeds a brief into a Gen AI system, what is it actually doing? What are the mechanisms behind the scenes that let it create something, well, feasible?
Okay, so the mechanism is, it's a huge leap beyond traditional CAD software, which is mostly just rule-based. We are looking at really advanced computational tools. The source material specifically points to neural networks and evolutionary systems. It's a really powerful combination.
Okay, so neural networks, I think most of us have a handle on that. Pattern recognition on a massive scale.
That's it. Think of it as an engine that's been trained on millions of successful past designs. It recognizes these deep relationships between a shape, a material, and how it performs. But the real magic, the ingenuity, comes from the evolutionary systems. That sounds suitably complex. So for you, the learner, looking for that quick insight, how does an evolutionary system even apply to something like architecture? It's actually a perfect analogy for design. The system starts by generating a population of hundreds, maybe thousands, of simple random designs. Think of it as the initial genome.
Okay.
Then it subjects every single one to the constraints you've set. This is the selective pressure. Does this design fail under a simulated wind load? Is it way over budget? If so, it dies off.
It gets eliminated.
It's gone. The strongest performers, the most structurally sound, the most cost-effective, they get bred together. They combine their best features to create a new, more refined generation of designs. And this whole cycle repeats, thousands of times a second. So instead of just tweaking one human sketch, the AI is exploring an entire universe of mathematically sound possibilities all at once. It's constantly iterating, constantly improving, based on those real-world rules.
So the process becomes much more dynamic.
Completely. The starting point matters less than the quality of the constraints you define at the beginning.
And that speed is the real competitive advantage here. Just harnessing that raw computing power lets firms explore design spaces that were, they were totally inaccessible before because of time or just resource limits. It democratizes complex creative exploration. Okay, let's pivot. We've established the AI can generate this universe of options. But if that universe is infinite, how does a designer stop it from just spinning into the ridiculous? How does the AI make sure that wild cantilevered idea is actually buildable and, compliant? This is where it really matters, the balancing act.
It manages that tension by basically building the constraints right into the input parameters. So the limitations stop being obstacles and they actually become guiding principles. The AI isn't just optimizing for novelty, it's optimizing for a solution.
A feasible solution.
A feasible one, yes. The source material breaks down the critical factors it can incorporate. We're talking detailed structural analysis, environmental things like solar gain or seismic activity. And this is critical regulatory factors, right down to specific local building codes.
So it's not just a checkbox that says, is this compliant?
Not at all. This is where the depth is. It's running these continuous micro-simulations. When it generates, say, a curved wall, it's immediately calculating material stress, the rebar density you'd need, the cost difference versus a straight wall. All of that happens in seconds.
Wow.
Or for a building that needs a lot of heating or cooling, It runs heat transfer simulations to propose different materials or small adjustments to the facade long before the concept is even considered final. It basically embeds feasibility and sustainability into the DNA of the proposal itself.
And that is the practical commercial benefit right there, that efficiency. By simulating material performance at the conceptual stage, Gen AI can optimize how much you use, which can massively reduce waste. So you're linking the most innovative ideas to cost control and environmental responsibility from day one.
Right, from the very beginning.
But I have to introduce some friction here. If the AI is so focused on mathematically optimizing for efficiency, structure, budget, materials, doesn't that risk creating designs that are, I don't know, a bit sterile, highly efficient, but maybe aesthetically boring? Where does the human creative flavor fit in?
That is a crucial question. The designer's role definitely changes, but it does not disappear. The human is responsible for defining the creative parameters, the aesthetic goals, the emotional feel, the functional needs that are hard to quantify.
So it's more about the why than the how.
Precisely. Instead of design a bridge, the prompt becomes design a bridge that minimizes embodied carbon, withstands a 100-year seismic event, and this is the key part, and evokes a feeling of lightness and connection. The AI then uses all its power to find the most efficient set of solutions that fit those emotional and visual rules. So the human becomes the curator, the director, the one who provides that unique contextual guidance that only experience can provide. The tool just makes sure the beautiful output is also grounded in reality.
That really shifts the perspective. Okay, let's move to the aha moment, the actual applications. Where are leading firms using this right now, taking these designs out of the computer and into the real world?
The applications are pretty broad, but the biggest strides are in architecture and urban planning, mainly because their constraints are so complex. In architecture, firms are using it for what's called multi-objective optimization. They're conceptualizing these highly sustainable buildings.
And it's not just about reducing energy use anymore, is it?
No, it's far beyond that. Take, for example, designing a high-rise in a dense city. The AI is juggling several things at once. It's minimizing the material for the shear walls, maximizing natural light deep inside the building, and making sure the facade's geometry minimizes heat gain in the summer.
Those are three competing goals.
They're totally competing goals.
Right.
And previously, designers had to make compromises, one after the other. The AI resolves them simultaneously. And that leads to these innovative forms that also serve a very clear function, like the self-shading building geometries that are starting to pop up.
That brings it to life. So we're seeing things that look futuristic, not as a style choice, but because the most optimized structure is the aesthetic.
Exactly. And then the complexity just jumps way, way higher when we move to urban planning. AI is becoming indispensable there. Urban layouts have to consider all these complex variables across an entire city grid.
It's not just where the buildings go.
Not anymore. It's about total efficiency. AI helps optimize complex microgrids by analyzing traffic patterns, pedestrian flow, shifts in population density over time, and environmental impacts like localized heating or water runoff. For instance, an AI can propose a road network that simultaneously minimizes travel time for cars, maximizes access for emergency vehicles, and integrates new green spaces to manage stormwater. It's juggling hundreds of variables a team of humans would take years to model.
So the overall impact is that the most innovative solutions we're seeing are optimized for cold, hard efficiency traffic, material load energy, and are also just striking in their design. The best of both worlds, produced at a speed we've never seen before.
And if we connect that to the bigger picture, it takes us right to the future of this human-AI partnership. How does the relationship between the designer and this powerful system actually evolve from here?
Right, what's next?
Well, we anticipate future advancements are going to be all about more intuitive interaction. We're moving past the AI just giving you a big portfolio of options to scroll through. Soon, it's going to engage in real-time design alteration.
Based on feedback from the designer.
Exactly. Based on spoken or even gestural feedback. A designer might just say, increase the transparency on the south facade by 10%, and the AI instantly recalculates everything. The structural integrity, the thermal load, the updated materials budget, all without the designer touching a keyboard.
That real-time iteration, that suggests a massive change the prototyping timeline. And that's the competitive advantage for you, the learner. The process isn't just faster, it naturally creates a much greater variety of feasible solutions. The human cognitive load completely shifts. It's less about the hard work of iteration, of the thousands of tiny calculations, and it's more about the strategic task of defining the vision, curating the results, and just ensuring the final design aligns with both the creative goals and the practical constraints. So to summarize our deep dive, this revolution in conceptual design is absolutely being driven by Gen AI. But the real breakthrough is the combination of human ingenuity defining the vision and the computational power of AI, making sure that vision is functional, efficient, and buildable from the get-go.
And that revolution leaves us with a provocative thought for you to carry forward. Conceptual design is no longer limited by the speed of a human hand or a calculator. Since Gen AI lets us quickly explore this vast space of feasible options, the most valuable skill for a future designer might not be generating a shape. It might be defining the most insightful and creative parameters for the AI to follow. So when you're faced with a design brief, what stands out to you as the most crucial constraint the AI should prioritize first? Is it structural integrity, a fixed budget, or maximizing environmental sustainability? Because that initial choice, it determines the entire trajectory of the final product.